Hello, so today we're going to be talking about matter, which actually might be a review from middle school, or it might be something you really touched on base last year in your physics class and stuff like that. But we're going to kind of just do a brief review, dive into a couple of key concepts that will deal with chemistry and the rest of the course as the year progresses. So first thing we need to ask ourselves, what is matter? Well, Webster's definition of matter is anything that has mass and volume. But to fully understand this definition, we need to define two key terms, which are mass and volume. First off, mass. Mass is the amount of matter an object has. So it's how that matter is rearranged and how much matter can be stuck within this particular object itself. It does remain constant. So for example, if I take my phone, the mass of this phone is constant, but if I break it up into little pieces, each piece will weigh a different, well, not weigh, it will have a different mass. But if I added all those masses up together, it should equal the mass of the phone. So no mass is created or destroyed in that process. It can just be rearranged. Volume is the amount of space that an object takes up. So this phone takes up a particular space in the air right now, and then it has a different volume than what this cup would have. So those are the two key terms of that. Again, this might be stuff that you already know, but it's always to have good review as well. One thing we want to really talk about is weight. A lot of people get mass and weight mixed up when it comes to scientific reasoning, so I really want to touch on this because it is a key difference you really need to identify in regards to chemistry. The definition of weight is a body's relative mass or the quantity of matter contained by it giving rise to a downward force, the heaviness of a person or thing. So in other words, it's how this mass is affected by gravity. That downward force is what we're talking about, is gravity. So gravity is pulling down on my mass, giving me a particular weight, which is the reason why if I get on a scale, we say weighing ourselves in. And I have a weight of whatever. So that's why we call that. But my mass is completely different than that. So again, weight is a measurement of the overall force being pulled down with your body in reference to gravity. Weight is related to mass, but it is not the same thing as mass. The reason why it's related is according to what's called Newton's second law, which you may actually be familiar with. So it's the force equivalent to the mass of that object to the acceleration of the force that's being brought down on this object. So for my weight, it's the force of gravity is equivalent to my mass of me multiplied by acceleration of gravity, which is 9.8 meters per second squared. So if you ever want to figure out what your mass is, you can always calculate your weight, turn it into kilograms, and then use this equation right here to calculate your actual mass, and then you can calculate the actual mass of that thing. So states of matter. This is really important. Some of these are really intuitive, but there might be a couple things we have not discussed before, you haven't seen in a science class. So I want to make sure that you are familiar with these things. So we'll go ahead and dive into this. So a solid is a matter that has fixed shape and has definite volume. So again, going back to the phone, it has a fixed shape. I can't easily bend or break this thing. It's kind of the matter put together is very cohesive, and it has a definite volume. Liquid, on the other hand, has a definite volume, but it does not have a fixed shape. So this cup has liquid in it. It occupies a particular volume of this cup, but if I swirl it around, which you can't really see, we know that the liquid is moving around, which means it's changing its shape constantly, but the volume doesn't change. Gas neither has a fixed shape or volume, so the air that's in this room right now, even though the room is particular shape, does not mean that that gas occupies that exact shape at all times. Nor does it have a definite volume, because that gas can be spread out to multiple places. I mean, there's gas going through the vents, through the windows, so on and so forth. So gas is the ones that do not have a fixed shape or definite volume. The next one is plasma. Plasma is not probably something you've heard about just yet. Plasma is the next step above gas. It is matter that does not have a fixed shape or definite volume, but it also means that its electrons from its nucleus has been stripped away. So a very common form of plasma is lightning. Lightning is ionized gas in the air to which it's getting so hot so much energy is going into it that the air molecules are losing their electrons, creating that bright light that we see through lightning. And it is a form and state of matter, but it's not the most constant form of matter. Plasma is very useful in regards to particular experiments that scientists do use. So I do think it's valid to acknowledge that this is a primary state of matter. Blood plasma is not the same thing as plasma, the state of matter. So just be aware of that. So kind of look at this chart, just kind of break this down if you wanted to put it in more of a tabular form. So a solid, does it have fixed shape, definite volume, electrons around the nucleus? Yes, yes, and yes. Liquid, does it have a fixed shape? We know no, but it does have a definite volume and electrons around the nucleus. Gas, no, no, and yes. Plasma, no, no, and no. So you can kind of see this form, this diagonal right here in regards to yeses being on this side and no's being on this side. So if this helps you in regards to remembering this, I would recommend maybe writing this table down or just, do your best to memorize that stuff as well. So properties of matter. So there's a variety of properties, some a little bit more intuitive than others. So we're going to dive into those a little bit. So matter can be assorted into various groups based on their many different properties. These properties include physical properties. They're characteristics that can be observed and measured without changing the identity of the substance. And we'll get further into what those are later on. Chemical properties are characteristics of a substance that can only be observed by changing it into a different substance. To imply something chemically has to happen for that to occur, for those properties to be seen. That is a particular property that deals with the changing of how matter is organized, going through chemical reactions, so on and so forth. Extensive properties is not something you've probably heard of yet. Extensive properties is a characteristic of a substance that depends on the amount of matter present. So the mass depends on the amount of matter present because different masses have different amounts of matter. Volume is dependent on that because different amounts of masses can occupy different volumes of space, and so on and so forth. Intensive properties are characteristic of substances that do not depend on the amount of matter present. So the color of it, the density is a very common one that a lot of people don't get. The density for any material is the same throughout because it's mass divided by volume. So you have these two extensive properties that kind of cancel each other out to make an intensive property. Because just because the mass and the volume may change, it means it must be a different material because that matter has to be organized a particular way, which means it chemically has to be bonded in a particular way to make that substance. And as long as that substance is constant, it will have the same density. So therefore, it does not depend on the amount of matter present. It just depends on what that substance is. So that may not make a little sense right now, but we'll kind of explore that further on in the class and throughout this video too. So kind of break this down into a more tabular form again if this is how you're wanting to do it. Let's take the characteristic of volume. Is it physical or chemical? Take a second to think. Same thing with extensive or intensive, even though we just went over that. It is a physical property because it does not require a chemical change to measure. And extensive because it does depend on the amount of matter present. Mass, same thing, physical and extensive. Density, it's a physical property because it does not require a chemical type of change or something to happen to the substance. The substance can just be by itself. As long as we identify what that substance is, it should have that same exact density for any of that same substance throughout the whole universe. But it is intensive because it does not depend on the amount of matter present. Boiling point is where we start getting a little bit more into that. It is physical, but it is intensive. So different materials have different boiling points based on the bonding energy between atoms, which means it's not necessarily dependent on the amount of matter present. It just depends on what that substance is. So, and it doesn't require a chemical change to identify that because it can be measured by the amount of energy between those bonds. So we don't have to, even though we provide heat and there is a change going on between ice and water to water vapor, the water is not changing, it's just changing states. It's not like water is becoming calcium chloride or anything like that. The water is just physically changing states with different amounts of energy being introduced. Reactivity is chemical. because to be reactive means to change. So if we have to change the substance, that means it has to be a chemical property. It's intensive because that particular substance will react always in the exact same way. It does not depend on how much more or less you have of it. It changes in a particular way depending on what it's exposed to. Conductivity is a physical property, because we can actually identify how those electrons move without changing the substance. Even though we may do experiments to help validate our reasons, it goes back to the actual substance itself. So it does not mean we have to chemically change it to allow conductivity to be measured. It can be measured just from the substance itself. It's intensive, again, because it doesn't depend on the amount of matter. The ability to rust means to pretty much to oxidize, to take in oxygen. Iron will take in oxygen to form rust. So that is a chemical change because iron is bonding to oxygen. But it is intensive because iron and oxygen are always going to react the exact same way. Doesn't matter how much you have of each, it will still happen that way. So to break down physical and chemical changes, just in general, just have some ideas here. A good physical change would be changing shape. So if I broke this phone in half, that would be a physical change. But chemically, the phone is still made of the same materials. I'm just breaking it in half. Size, same thing. Phase or state of matter. So so going back to the water example, I have an ice cube, it melts, turns into liquid water, and then I heat it up, and then it turns into water vapor. The water molecules are the only things in there. So it's just the water changing states itself. The water molecules are not changing themselves. Okay? It just means that the water molecules are just spreading further and further out to make different states. They're not chemically changing. They're not rearranging their atoms to become new substances. Chemical change goes through a chemical reaction. So if I take sodium and put it into water, you'll see sparks and everything fly around. That is a chemical change because it's forming a new substance. Rust, again, iron reacting with oxygen is a chemical change. Decomposes. So when things die, they decompose. The only way it does that is that through the environment and what's going on with your body, it creates it into a substance to where it allows decomposition of the body. So that is a chemical change because new substances are being formed in which your body will decompose and so on and so forth. Burns is a chemical change too. So if you get a burn on your arm, like a really bad burn, that heat or that reaction that you're feeling is heat that's actually coming off of a chemical reaction that's occurring on your skin. And that's why your skin will change colors and stuff, is because with those new substances forming, it's bending light in a different way, which causes you to see black or red or so on your arm. So that is a chemical change in itself. So classification of matter. Matter is classified and broken into two main categories. The first one is a pure substance, and it sounds exactly what it looks like. A substance made up of only one type of particle, or one atom, one molecule. They're exactly the same thing. So if I take water and I have purified water, also can be called distilled water to an extent, it's just water molecules in there. There's nothing else. So it's a pure substance. It's a pure glass of water, so on and so forth. A mixture sounds exactly what it means. It's a variable combination of two or more pure substances. So it just means that it's something that's made up of two or more different types of particles, atoms, molecules, elements, so on and so forth. But each substance keeps its individual properties. One thing we'll come to learn way later on in the year is something called aqueous solutions, which means that we make solutions of other chemicals like acids and bases, but they're in a water-based solution, which means there is water in there, but water will react in a particular way compared to whatever acid may be in there too. They may be floating around and doing their own thing, but they react in two separate ways. You just can put them together and use that for further experiments. So pure substances, there's two types of pure substances. There's an element, which is a substance made up of only one particular atom. We kind of dove into this a little bit with and we'll dive a little bit further into what it is with atomic structure and everything like that. Compounds is composed of two or more elements in fixed ratio. So sodium chloride, salts, stuff like that, those are compounds. Element is just hydrogen, oxygen, so on and so forth. The properties differ from those of individual elements because based on how those elements combined, they can produce other properties. They can produce, like salt will, do specific things to water compared to glucose, which is sugar. When you throw it in water, it'll do exactly something else. So those are two different things. The way atoms are rearranged depends and determines their type of reactivity with other things, water, so on and so forth. Chemical bonds hold elements together, so we know about that. We'll dive further into that in the next couple of units as well, but just be aware that's what holds those elements together. Going on to the law of definite composition, this is something that's a little bit similar to conservation of mass and energy. It's derived from those two, but it's a separate law of itself. And what it says is that a given compound always contains the same fixed ratio of elements. So in other words, CO2, which is carbon dioxide, will always be CO2. You can't call CO2 something else. Okay? CO2, there can't be two different CO2 molecules where they have different properties. They're the exact same thing. So there's always going to be one carbon, two oxygens when it comes to carbon dioxide. Same thing with water. Two hydrogens, one oxygen, two hydrogens, one oxygen. They're all going to have the exact same properties. But CO2, carbon dioxide, will never be water. Okay? Because there's completely different elements, different ratios, and they have completely different properties. So that's all that law of definite composition is. So when I say carbon dioxide, you should always think CO2, and that's the law of definite composition. So on and so forth. Okay, going into mixtures, there's two main types of mixtures. There's a heterogeneous mixture. It means that there's two or more visibly distinct parts. So hetero mean different. Geneous means together, mixed. So there's two or more distinct parts. Each part has different properties, so two different elements, two different compounds are in together, so on and so forth. So they all keep their individual properties. Homogeneous mixture is the exact opposite of that. It means evenly mixed but has no different parts. So it means that, pure water can be a homogeneous mixture. Okay? So it's a homogeneous mixture where it's evenly spread out, occupies a similar volume, they have no different parts, it's all the same molecule, so on and so forth. And again, it has the same properties that the substance because that substance should be all the same. So one thing that we try to do is we kind of break this down a little bit in regards to a flow chart. So if you want to copy this, I highly recommend it. So I'll kind of go through this one by one with you. So at the top of the flow chart is matter. It just encompasses all things. First question you want to ask yourself, can it physically be separated? If your answer is yes, then it becomes a mixture because you can physically separate two different things. Okay, two or more different things, which is what classifies as a mixture. If you say no, then it's a pure substance. So when we're going to evaluate mixtures even further, it says, does it look the same throughout? If your answer is no, it's a heterogeneous mixture. If you say yes, then it's a homogeneous mixture. And then on pure substances, you ask, does it have two or more different types of atoms? If you say no, then it's an element, because it's just something of one particular atom throughout. Or if you say yes, then it's what's called a compound. All right, so that's the end of this video. If you have any other questions, please come see me, email me, talk to me, whatever you need to do. Otherwise, thanks for joining me. I hope to see you in the next video, and see you in class. Bye.